Hello, physics. This is Chapter 8, Homework 3, Problem 1, which we did as we do in class today. So what's going on here? Alice and Billy sit at rest in rolling chairs facing each other with their feet pressed together. Alice and her chair have that mass. Billy and his chair have that mass. They're going to push off of each other, and Alice and her chair are going to move to the left with that velocity. And we want to figure out how fast and in what direction does Billy move. So grab the red pen. Do step 1. So step, how fast and in what direction does Billy move? So we want velocity of Billy final. It's his velocity at the end of this situation. And that's going to be equal to question mark. And because it's velocity, it will have units of meters per second. Now, in a conservation of momentum problem, your next step will be step 1. And anytime you're doing a law with any kind of conservation law, you actually want to make 2 sketches. Your first sketch, your initial sketch, will be the beginning of your situation. So if you look at the law of conservation of conservation of momentum, it's that side. So what's happening at the beginning of our situation here? We have the ground. We have a rolling chair on wheels. And we have Alice. So Alice has her feet up. So there's Alice. She's got her feet against Billy's feet. So here's Billy, and he is also in a rolling chair. Now we know that the mass of Alice, that is 62 kilograms. That's the number right there. So M sub A, that is an A, is equal to 62.0 kilograms. The mass of Billy is 72 kilograms. Now we're also going to care about V sub AI, the velocity of Alice initial. Well, notice initially Alice is not moving. There's no speed lines. So Alice's initial velocity is 0 meters per second. And same thing with Billy. He's not moving at the beginning of the situation. So V sub BI is also equal to 0 meters per second. Then you do your other sketch, your final sketch. So your final sketch is going to show you what's going on here on the right side of your equal sign. So what do we have here? We have the ground. We have a rolling chair. So here's Alice, and she's moving to the left. So we're giving her speed lines going that way. And if she pushes and goes to the left, well, that means Billy is going to end up going to the right. So here's Billy. Here are Billy's speed lines. So he's going to the right. We're going to care about V sub AF, the velocity of Alice final. Now, Alice is moving to the left, so keep that in mind, with a velocity of 2.25 meters per second. So that's going to be 2.25 meters per second. Now, I know it's to the left, but I'm not making this number negative for math reasons. I know that it's to the left because there are speed lines indicating that she's going to the left. And I'm also going to draw a little arrow over here to remind me she's going left. And what is V sub BF? Velocity of Billy final? Well, this is what we're looking for. We don't know this. So that one is question mark meters per second. So step 2 in a conservation of momentum problem is to write the law of conservation of momentum. So yeah, the next thing you write should be literally this exactly. Sigma P initial plus J external, both of those are wearing hats, is equal to sigma P final with a hat. So I just copied this. This is the big idea we're going to use to solve this problem. Now, first thing, J external, external impulse. There is no external impulse in this problem. External impulse would be if Charlie comes up and shoves somebody with, 100 newtons for 2 seconds. That would be external impulse. We don't have that happening. We don't have anyone wearing a jetpack, putting a force for a time, anything like that. So therefore, J external is just going to be 0. So that term is going to end up being plus 0. Now, sigma p initial. The way you get this term is look at your initial sketch and figure out where all of your momentum is. So I'm going to write, for reasons, I'm going to write this, p sub ai with a hat plus p sub bi with a hat. Initial momentum of Alice plus initial momentum of Billy. Now, in this particular problem, no one's moving in the initial picture. So both of these numbers are going to be 0. But in general, you might get problems where one or both things are moving at the beginning. So in general, they won't be 0. In this one, they are. So I wrote them, but in fact, both of these guys are going to be 0. So they go away. We end up with a 0 plus 0 plus 0. So the whole left side ends up being 0. All right. Now on the right side, sigma p sub f, sum of your final momentums. Look at your final sketch and figure out where all of your momentum is. So Alice is moving. She's got momentum. So there's going to be p sub af, momentum of Alice final, and Billy is moving, plus p sub bf, momentum of Billy final. So what we end up with is 0 is equal to p sub af with a hat plus p sub bf with a hat. So that is step 2. Step 3 is the math. The first part of the math is going to be to take the hats off and put in your signs. So the left side is 0 equals P sub AF, momentum of Alice final. She's moving left. So we're going to call that one negative. So P sub AF without a hat, and there's a minus sign in front of it because she's going left. Billy is going right. So when I take the hat off of that one, that ends up being plus P sub BF. So we have that. Now, at this point, there's different ways you can do this. What I would recommend doing now is turn all of your P's into MVs and turn all of your J's into FTs. If there is J in this problem, turn that in FT. We don't have any J, so we don't have to do that, but we are going to turn our P's into MVs. So minus P sub AF is going to become minus M sub A V sub AF plus P sub BF is going to become M sub B V sub BF. So my P's have become MVs, and if I had a J, I would turn it into an FT, but I don't have a J here. So at this point, I've got 4 different variables. The one I'm looking for, remember, is V sub BF. So I've got to get V sub BF by itself. So the first thing I'm going to do is add M sub A times V sub AF to both sides. That will give me on the left M sub A, V sub AF. On the right, that just cancels, and I will end up with only M sub B, V sub BF. Now to get the M sub B away from this term, I'm going to divide both sides by M sub B. So on the right side, the M sub B's cancel, and I only have V sub BF all by itself, which is what I want, and I've got this stuff on the left side. So now I will switch left and right, and I'm going to end up having V sub BF is equal to M sub A, V sub AF over M sub B. And I know what all of these numbers are, so I just have to plug them in and do the calculator work. M sub A, that's 62 kilograms. So 62.0 kilograms. V sub AF, V sub AF is 2.25. So let us look at that number. So 2.25 meters per second. Now remember, Alice is going left. So why isn't it negative? It's not negative because I've already dealt with the leftness of Alice's velocity. So this idea here that Alice is going to the left, I accounted for that right here. When I took the hat off and I made it negative, I've dealt with the leftness. You do it one time and one time only. You don't want to accidentally make it negative again, because if you multiply it by -1 twice, you've made it positive, which isn't what you want. So I've dealt with that there. And then don't forget to divide by M sub B, which is 72 kilograms. So if you do all of that and you do it correctly, let me point out, kilograms times meters per second divided by kilograms, well, the kilograms will cancel. So this is going to leave us with something that has units of meters per second, which is what we want. If you do this all correctly, you will end up with some number that rounds off to 1.94 meters per second. Now, we also wanted to know the direction. Well, the fact that it's a positive number implies that it's to the right, but let's just write it in. It's going that fast to the right. Okay, so you put a box around it. So your physics teacher knows that that is your answer. And then you do step, remember we were looking for V sub BF, and we wanted it in units of meters per second. Well, we have V sub BF, and we have it in units of meters per second. So far, so good. Now, our number is 1.94 meters per second. So that's pretty close to 2 meters per second, which, if you remember your bloody cheetah, you take the number and double it. So 2 meters per second is pretty close to 4 miles per hour. So 4 miles per hour seems like a reasonable speed for someone in an office chair to be moving to the right with. So we're happy with that. You give it a check. So that is how you do a conservation of momentum problem. Hopefully you found that helpful.